In this video, we're going to look at non-standard maximization and minimization problems. Sometimes these are called mixed constraint problems because the constraints are sometimes less than or equal to, and sometimes they are greater than or equal to. So let's take a look at a problem and explain what I mean by that. So in this example, we are asked to maximize p equals 4x plus 12y plus 6z. So this looks like a maximization problem like we've seen before. And we have three constraints plus the non-negativity constraints. And the first constraint, we have x plus y plus z is less than or equal to 100. And the second one, 4x plus 10y plus 7z is less than or equal to 480. And both of those are exactly what we would want if we were working with a standard maximization problem. The inequality signs would be less than or equal to. However, in the third inequality, x plus y plus z is greater than or equal to 60. Because this is a greater than or equal to sign, this is not a standard maximization problem. So we say that these constraints are mixed. And because we have mixed constraints in a maximization problem, it is non-standard maximization. So we need to learn how to deal with a non-standard maximization problem that has mixed constraints. And it's a little bit different. So the first thing we want to do is to take the linear programming problem and create a system of equations, which is the exact same thing that we did when we had a standard maximization problem or a standard minimization problem after we created the dual problem. So we start with the first constraint, and we change the less than or equal to sign into an equal sign, and we add our slack variable s. Second constraint was also a less than or equal to sign. We replace that with an equal sign, and we replace that with the slack variable t. Now in the third equation, because x plus y plus z is either greater than 60 or equal to 60, and we're changing it to an equation where it has to be equal to 60, well, if the situation was that x plus y plus z was greater than 60, and now we're making it equal to 60, it would be, the left-hand side would be too large. So rather than adding a slack variable, we need to subtract something from that side, okay? Because the left-hand side would be larger than 60 possibly. We want to make it equal to 60, so we would have to subtract something. So we subtract the variable u, and now we're going to call that a surplus variable. Don't get too hung up on the terminology, whether it's a slack variable, a surplus variable, but what you really need to know is that when you have a greater than or equal to, you are subtracting the variable rather than adding it like we have been doing with the standard maximization problems. And then finally, we take the objective function, we subtract each term on the right over to the left, and so we end up with negative 4x minus 12y minus 6z plus p equals 0. So far, the only difference is this surplus variable. We are subtracting it rather than adding it. All right, setting up the initial table is exactly the same. Once we have our system of equations, we create the table. And so we will start with an x column, a y column, and a z column, STU for our slack and surplus variables, p, and then the constant column. And so we just fill in, just like we've done before, from our equation. We take variables. So x, we have 1, 4, 1, negative 4. So we have 1, 4, 1, negative 4. For y, we have 1, 10, 1, negative 12, etc., etc. Okay, so once we have that, we label our active variables over here, which are the same as the slack and surplus variables, S, T, U, and P. So setting up the initial table is exactly the same. All right, now, whenever an active variable is negative, we star the corresponding row. So what do I mean by that? So we know that S, T, U are active variables. So let's determine if they're positive or negative. So remember how we find the value of the active variables. We always start with the number in the constant column, which for S will be 100. And then we divide that by the number in the S column and the S row, which is 1. 100 divided by 1 is 100, but the important thing is it's positive 100. T, we take 480 and we divide it by 1. That's 480, and again, the important thing is it is positive 480. For U, we have 60 divided by negative 1. Aha, that's equal to negative 60. So U, one of our active variables, is negative. And the reason for that is because of this negative 1, which came from the surplus variable. So for every surplus variable that you have, you are going to have a negative active variable in your initial table. So since we only had one surplus variable, we're only going to have one negative active variable, which is going to be the U. All right, so why do we need to know that? Well, getting started, finding the pivot is a little bit different now. So I highlighted U by just coloring that in purple and putting a little asterisk. I don't care how you do it, but just make sure that you know that this row, the U row, it has a negative active variable in it. So to find the pivot, what we want to do now is we go to our starred or our highlighted row, which is the U row. Okay. Now, normally with a standard maximization problem, we go to the bottom row and we look for the most negative number. We are not going to do that now. We're going to our highlighted row, the one with the negative active variable, and we're looking for the most positive number. The most positive number. So the most positive number is either 1, 1, or 1. They're all equally positive. So pick one. Doesn't really matter which one you pick. I always like to go to the left-hand column if that's possible. So I am picking the X column as my pivot column. Right? Then once we have determined the pivot column, finding the pivot is exactly the same. We look for ratios. So 100 divided by 1 is 100. 480 divided by 4 is 120. 60 divided by 1 is 60. We're looking for the smallest ratio, which is 60. So 1 then is our pivot. So the only difference here was how we found the pivot column. Once we found the pivot column, we find the pivot in the pivot column exactly the same way that we've done it before. Now we want to clear the X column, which means we want all zeros except for that 1. And so doing that is exactly the same. Okay? We clear the first column. And so this process I'm calling phase 1. All right? Phase 1 is what we're doing right now. This is the new part. So we have the new table, our second table, and we look to the bottom row and we notice that we have negative values. So that's the same. If we have negative values in the bottom row, we are not done, and we're going to have to do the process again. So the first thing we want to do is, this is part of phase 1, is look for any negative active variables. So again, I'm going to look at the S. So that's 40 divided by 1 is positive 40. T is 240 divided by 1 is positive 240. X, and remember we replaced the U with X, outgoing and ingoing. That's exactly the same. So X is 60 divided by 1 is positive 60. So all of our active variables are positive. Once all of our active variables are positive, we're done with phase one. Okay, let me repeat that. Once we have all positive active variables, we are done. We are completed phase one. And so we start phase two. Now, what is phase two? Phase two is what we've been doing. When you did a standard maximization problem, that was what we're now going to call phase two. And so phase two, we go to the bottom row, we look for the most negative number, and that becomes our pivot column. We then look at the ratios to determine the pivot in that column. We then clear that column, and we get a new table. Okay, so everything we're doing now in phase two is exactly the same. And so now I look at the bottom row, and I have all positive numbers. So I am done, which means I can determine the values of my active variables. So S is going to be 40 divided by 1 is 40. Y, and of course we replace the T with the Y. I always forget to mention that. So Y now is 240 divided by 6, which is 40. X is 120 divided by 6, which is 20. And the value of P is 3360 divided by 6, which is 560. And then everything else, other than the active variables, all the inactive variables are, of course, all zeros. And so this is our solution. The optimal value is P equals 560. It occurs when X is 20, Y is 40, and Z is 0. So that's the first example. Let me do one more example quickly and emphasize the differences. So I'm going to go to example 2. So we're asked to maximize, but we notice that we have mixed constraints. We have a greater than or equal to, a less than or equal to, a greater than or equal to, a less than or equal to. So this is a non-standard maximization problem. First step, create our equations. Because the first inequality is a greater than or equal to, we're going to have a surplus variable. We subtract it. So we're going to start with S, so we subtract S. In the second inequality, we have a less than or equal to, so we add the slack variable. In the third inequality, again, we have a greater than or equal to, so we are going to subtract the surplus variable. And the fourth inequality, we have a less than or equal to, so we will add the slack variable. And then our objective function becomes minus 2x minus y plus p equals 0. And we have completed that step. So the difference here is knowing when to subtract these surplus variables rather than adding them. Creating a table is exactly the same. Right? So we create the table. We just take our equations and we transfer everything into a table. But now we want to determine where we have negative active variables. Well, anywhere where we had the negative surplus variable, we're going to, in our initial table, have a negative active variable. And so we can see that for S, we have 35 divided by negative 1 is negative 35. U is 60 divided by negative 1 is negative 60. So we highlight the first row and the third row. So we begin phase one. To begin phase one, we have to find the pivot column, but we do that by going to either one of the highlighted rows. It doesn't matter which one. I'm looking at the first one, and so remember what we have to do. We want to look for the most positive number. Well, X and Y are both equally positive, so I could arbitrarily pick either one of those. So I don't like doing that, so I have another option. I'm going to go down to the other highlighted row, and now I definitely have a choice. 2 is more positive than 1. So I'm going to pick the X column as my pivot column because it has the most positive number in that row. And again, I'm choosing this row because it's one of my highlighted rows. Determining what the pivot is in this row is exactly the same. We use ratios, and so doing that, we end up with 1. All right, so this is part of phase 1. So we clear the row, clear the column, and we get the second table. Boom, there's my second table. And so we have to determine if we have any more active variables that are negative, which we do. So S is an active variable. And so 10 divided by a negative 1 is a negative 10. So I highlight that. T, 35 divided by positive 1, positive. U is 10 divided by negative 1 is a negative 10. Highlight this row. X, remember we replaced the V with X, outgoing and ingoing active variables. And so X, we have 25 divided by positive 1 is a positive. So we have two negative active variables, S and U. So I highlight those two rows. To determine the pivot column, we go to either one of our highlighted rows. And I like to use the one, again, that's going to give me the best answer. So if I go with the first one, the most positive number is in the Y column. If I go to the third one, the most positive number, again, is in the Y column. So I guess I'm going to use the Y column, is my pivot column. Once we're in the Y column, we look for the smallest ratio, which will be 1. And now we clear in the standard method using row operations. And so we come up with our third table. And in the third table, I want to determine if I have, first of all, in the third table, we know we're not completely done yet because I have a negative in the bottom row. Okay, just like up here, I knew I wasn't done because I had a negative in the bottom row. So the question is, am I still in phase 1 or do I go to phase 2? And so to determine that, we look to see if we have any negative active variables. And it just turns out now that all my active variables are now positive. So we replaced the S with Y. So Y is 10 divided by positive 1 is positive. T is 15 divided by 1 is positive. U is 0 divided by anything will be 0. X is 25 divided by 1 is positive. So all my active variables are positive, which means I now go to phase 2. Phase 2 is the good old stuff that we learned last week. So we go to the bottom row, we look for the most negative number, which is the only negative number, which is negative 1. That becomes my pivot column. And I look for the positive number with the smallest ratio, which I guess is going to be 0. 0 divided by 1 is 0. And so we clear that column. And we end up with another table. And I look at the bottom row, and still have a negative number. So we have to continue. Now, once you get rid of all of your negative active variables, you shouldn't end up with any more negative active variables. And so we'll stay in phase 2, but you could always check that if you wanted to. You could say, okay, my active variables, 10 divided by 1 is positive, T is 15 divided by 1 is positive, S is 0, X is 25 divided by 1 is positive. So we're still in phase 2. And so my pivot column will be the U column. Smallest ratio in that column will belong to the row with the 2 in it. And so now we clear that column and we end up with the next table. And now I look at the bottom row and everything is positive. So we are done. So we go to the active variables. Y is equal to 35 divided by 2, which will be 17.5. U is 15 divided by 2, which is 7.5. S is 15 divided by 2, which is 7.5. X is 25 divided by 1, which is 25. Everything else is 0. Z is 0. T is 0. V is 0. And of course, P is 135 divided by 2, 67.5. So the optimal solution is 67.5, and it occurs when X is 25, Y is 17.5, and Z is 0. Okay, one last thing. This is getting to be a long video. Minimization problems. Actually, I'm going to do this in the next video. I think that's long enough for this video right now. So I hope this was helpful. I'm also going to make a couple more videos where I'm actually going through and working through the examples step by step. So let me know if this was helpful. Thank you.